It's okay.
Okay, so I think I must have hit it twice, and so it turned it on and off at the same time. I see right now it thinks it's recording, so we'll let it record.
I see record.
Oh, you can see it too?
Yep.
Okay, good. So it's everybody's job to help me remember to record and to make sure it's recording when I think it is. Okay, now we're going to go back to... Okay, so again, probability is just the likelihood something is going to occur. And we can talk about two kinds of probability. Here it is. One is a theoretical probability, and that's the one that we get just by looking at the situation and making a judgment how often it should occur. And the best example for that is if you have a number cube, it has 6 sides on it, 6 different numbers. If you throw that die, what's the probability that it would land on a 5? Well, there's only one side that's 5 out of 6 sides altogether, so it's 1 out of 6. That's based on theory, and you can come up with that just based on the physical situation. Experimental probability is when you do an experiment and count the number of times that it happens. So if I gave each of you a number cube and I said, roll it 1,000 times and count how many times out of 1,000 that it turns up as a 5, you'd get a probability, but it would be based on the experiment that you did. And so as you're taking the GED test, it may ask you the difference between experimental or theoretical. And the best way to remember it is just thinking about this word right here, experimental. If you do an experiment,
that kind of proves it.
It's experimental probability. Yeah, what did you say, Kevin?
Kind of proves it by experimenting. Just doing it.
Yes, it does. And scientists do experiments all the time. And oftentimes they do an experiment because they already have an idea of what it should look like. So they come up with a theory, and then they do an experiment to try to prove their theory. Just like what you're talking about, Kevin, it might prove it. What happens often is in real life, when the scientist does the experiment to prove the theory, sometimes they don't come out the same. And if they don't come out the same, it's probably because the scientist did not consider all of the variables or all of the whole situation. There's something else about it that's unknown. So yeah, has basically the same meanings as in science. Okay, so a typical probability problem, there's only a few that you'll see. You'll see rolling a number cube. You'll see drawing marbles out of a bag. You might see a spinner. And the other one that it might have is using a deck of cards. And you know, what's the probability of, if you have 52 cards and you're going to just pick one at random, what's the probability that it would be red? And questions like that. Okay, so let's look at this example here. There's 10 marbles, there's 7 striped and 3 black marbles. So we're going to have Mark draw a striped marble. He does not replace it in the next 3 events. Mark draws 2 striped marble and 1 black marble. He does not replace those marbles either. What's the probability that he will select a black marble on the 5th event? Now, they've intentionally come up with a really complicated little story here. But actually, what the question that they're asking it is really easy once you sort through all the words on this word problem. So, first of all, we start out with 3 black, 7 striped, for a total of 10. He's drawing marbles out of the bag. And first, he draws a striped marble and doesn't put it back. So now there's not 7 stripes in there anymore. Now there's 3 black and 6 stripes. And there's only 9 total. Then he draws 2 more stripes and 1 black. Well, now there's only 4 stripes and there's only 2 black marbles left. It's total. Okay, now he's going, okay, what's the probability that he will select a black marble on the 5th event? We have to answer that based on this situation right here. There's 2 blacks for a total of 6. So it's really simple. It's 2 times 6. And when we put that into the calculator to see if it simplifies, indeed it does, it'll come back to 1 out of 3. And there's that answer right there. How do you like that one? Right off the bat, this particular book is making you convert it into that form right there. Questions about that one? Let's look at a spinner. Okay, Maud uses a spinner to conduct a probability experiment. On the first spin, what's the probability that the spinner will land on 6? I only see one section that has a 6. There's 8 sections altogether, and this is important, all 8 sections are the same size. If we had a spinner like this, and had this. Oh, that's terrible. That's not even believable for a spinner. There. What do we want? A 6. Oh, I didn't make enough. I'm going to make some more. Okay, so on this spinner, what's the probability of getting an 8?
1/2.
It's 1/2. Yeah. There's 8 sections and only one of them is 8. But since they're not the same size, 8 is 1/2. Okay. But over here, they're all the same size. So what's the probability of getting a 6? It's going to be 1 to 8. Now, Maud is going to spin the spinner again. What's the probability that it would land on a 4 or an 8? So if we think about this, if it's a game, and you win if it lands on a 4, and you win if it lands on an 8. Well, looks like there's 2 ways to win, right? 2 ways out of 8 sections altogether. This doesn't look like any of those answers either, does it?
Damn, that's what I was getting. Oh, that's totally what I was thinking about. 2/8, because there's like 2 numbers. Because you said 2 numbers.
Yeah.
That makes sense.
Yeah, so the 2/8 part makes sense, but it doesn't look like any of the answer choices. What in the world are we going to do about that?
Convert it into a decimal?
Oh, let's convert it to a decimal. Do you know how to do that, Kevin?
I know how to do it on the calculator.
Yeah, what do you do on the calculator?
I think you use the those 2 arrows.
Oh, okay. Yes, that's one way to do it. Let's do it that way. So we can put it in as a fraction. And when I hit enter, it just simple. But if we want to turn it into a decimal, we can use this key here, the toggle key, and it turns it into a decimal.
Yay.
Yeah, now what did your calculator do to turn it into a decimal? I can tell you exactly what they did. They did this operation right here, which stands for
Division.
Yeah. Okay, so we have 2 out of 8. We could have just gone 2 divided by 8. You can't see. There you go. 2 divided by 8. You hit enter and you get the 0.25. Okay. Now it looks like this answer right here. See, they're testing a couple of things all at once in these questions. Maud spins the spinner twice. She lands on a 4 and then on a 6. So far, what is her experimental probability of spinning an odd number? Oh my gosh. This is asking a bunch of stuff. It's asking if you know the difference between even and odd. It's asking you for a probability. And then it's also asking for if you really know what experimental means. Okay. So spins it twice. The first time she lands on a 4. The next time she lands on a 6. Okay, so, but it's saying what's the experimental probability of spinning an odd number? So is that an odd number?
No,
No, thank you, Brittany.
you're welcome.
Is that an odd number? No. So how many times has she spun an odd number?
0.
0. And how many times has she spun?
Twice.
Here we go. That's her experimental probability of spinning an odd number. Now, if we think about, oh, wait. Yeah. Yes. Wait, is that right? Yeah, that's right. That's what she's done. Experimental probability is going to be the number of desired outcomes out of the total number of trials. A trial just means a time that you try it. Okay. Now, Maud spins the spinner 2 times. What's the probability she lands on an odd number and then on the number 2? So, didn't give us any results. So, they cannot be asking for experimental probability. This is theoretical.
2 and 2. Let's see.
So for this one, since there are 2 events,
2 times what is
odd number
she landed on
and on
2.
the number 2. This is one of those where we're going to have to multiply to figure out the overall probability. And I'll draw a picture of it so that we can figure it out. So the spinner has 8 sections. We're going to use this side for the first spin and this side for the second spin. That first spin has 8. Oh, wait a minute. It's on an odd. Okay. So for the first spin, we're just going to look to see if it's odd or even. And there are exactly 4 odd numbers and exactly 4 even numbers. So I could say that half of them are even and half of them are odd. Okay. For the second spin, we're looking to see if it lands on the number 2. Well, there's 8 numbers. There's the 8 numbers. So we could do the Punnett square thing here. This square stands for an even and a 1. This square is even and a 2. This square is odd and a 2. And that's what we were looking for. And this is going to be the only square that ends up being odd and 2. So out of 16 squares altogether, there's only 1 that's odd and a 2. So when we get to this, we could take 1, since these are in decimals, we can take 1 divided by 16 to convert our fraction to a decimal. And 1 divided by 16 comes out to be this one right here, 0.0625. Here's a better way to do this without drawing a picture. I like to show the picture so that, the picture is easy to see why it works this way. The way to do this without drawing a picture is just to figure out what's the probability that she lands on an odd. Since half the numbers are odd, I know that that probability is going to be 1/2. And then we're going to multiply that by the probability of landing on a number 2. And that would be 1 out of 8. And when we multiply these two fractions together, you multiply fractions, you multiply the top, you multiply the bottom. It's so easy. Comes out to be 1/16, exactly where we were there. This is definitely a shortcut compared to drawing the picture. Oh, yeah. Somebody's upstairs in every business figuring this kind of stuff out. A large chain store keeps track of its daily customer complaints. 4 different departments and different complaints. It looks like electronics gets the most complaints. Imagine that. What is the probability that the next complaint call to the store will concern clothing? So we're going to base this on this data that they've given us. And it's just a probability. It doesn't guarantee that the next call is going to be about clothing. The first thing we have to know is what's the total number of complaints. So I'm going to add them up. 6 and 4 is 10, 12, 15. So there's 15 total. So clothing makes up 3 out of 15 of the complaints. All the answers are in percents, but we know how to convert things to percent. So we can go 3 times 100 divided by 15. And did you get 20?
Yep.
What's the probability that the next complaint will concern electronics or housewares? Since we're doing electronics or housewares, that means it could be either one of these. So you kind of have, oh, I'm pointing and you can't see that. You have to add these two up because they both win. Okay. So 6 and 4 is 10. So there's 10 ways out of 15 that it could be electronics or housewares. And, oh, good. All the answer choices are in fractions. So easiest thing to do is just put that in the calculator as a fraction and see if it simplifies. 2/3 right there. What is the probability the next call will concern a department other than electronics? So, there's 2 ways to do that. I guess an easy way to do it, it's not going to be electronics. It could be any of these. 3, 4, 5. So that's 9 out of 15. And then let's see the answers. Again, in a decimal. So convert a fraction to a decimal. You just do this operation here, which always means divide. 9 divided by 15 is 0.6. Oh, and I like this. Hopefully you'll get a question just like this on the test. Okay, Ian read in the newspaper, 40% chance of rain tomorrow. What's the probability that it will not rain tomorrow? You have to think about what's the other part of, I mean, if it was a circle graph and 40% of it is rain, we can think about what's the other part of it. This part is 60%, and I get that by just taking 100%, and we're going to take out the 40% chance of rain, leaves us with 60%. Now we have to convert a percent to a fraction. How do we do that? Oh, I don't know what to put on the bottom or the top. I don't even know if I'm supposed to put it on the top or the bottom. So this probably isn't going to help us. Let's just do this. Well, they're in fractions. Okay, so we can just put this into the calculator. And since you have a percent in the top and the bottom, you can just leave the percent off. So we can put it in just like that. 60 over 100. And it simplifies to 3/5. There. So, hopefully you've noticed that a lot of these problems, they're all kind of the same. You have to know the part, you have to know the whole. Sometimes you have to convert a fraction to a decimal. Sometimes you have to convert an answer to a percent. sometimes you have to leave it in fractional form, and sometimes you have to put it in this weird form here. So a lot of little detail stuff, but hopefully the mathematics is starting to feel okay. Any questions on this?
Fractions are my worst. I'm bad at fractions.
Kevin, every student tells me that, except occasionally there'll be someone who is a professional carpenter and they've been taking
Yeah.
measurements for 20 years and they feel pretty good at fractions.
Yeah.
But for everybody else, fractions are they're just weird. And part of the reason is that we use fractions to represent many different concepts. So they just seem to get confused.
It's funny. My uncle works on framing and he's good on fractions. And
I bet.
I don't understand. I gotta understand fractions. I'm learning, refreshing everything, but it's just it was crazy.
People who work in the United States or in the United States as a construction or a carpenter, they're used to using fractions like 1/12 or 1/3, 5/8, all the things we find on our rulers. The rest of the world gets to use fractions like 1/10, 1/100th, 3/10. All the fractions have a bottom of either 10 or 100 or maybe 1,000. So it's easier for the rest of the world. It is for those of us who use inches. Let's see, what else I can't remember what else I wanted to do today. I'm going to look at the schedule and see what's on here. Count, expand probability. Okay. Here. I guess it's probably worthwhile to look at a couple of things out of KET. If you want to, you can be in KET and looking at the same thing I'm looking at, or you can just look at my screen and be in KET. Either way works for me. I'm going to go ahead and see if I can bring it up.
Probably.
And yes, that. Okay, so now I'm going to come back and I'm going to share. Which one looks like KET? Oh, I don't want to share that yet. Let me go to dashboard. Okay, now I'll share. I had Joseph's grade book scores up there for a minute, so that wouldn't have been very polite to share that to the whole world. Basic. Find it. There it is. Okay, here we go. So I think here's what we're going to do. When you guys get here and you click pretest, then that shows, is this where it shows you results and it shows you your study plan? Yes?
Yeah, not in the pretest. I put in the, right there.
And since I'm the teacher view, so it treats me differently. So instead of getting a study plan like you guys get, I just get a list of all of the lesson review.
Mhm.
And this is something you can choose lesson reviews somehow. And this gives you grades that show up in the grade book. But a lot of people don't ever get to the lesson reviews. So we're going to work a few of these. And let's go to, let's see how well we can do on this. So this is on probability models and sample space. It should be about as challenging of questions as you would get on the real GED test. So, it looks like I personally have already worked a few of these. So, oh, and look, I got the wrong answer for question 4. So I'm just going to go ahead and bring up a new question. Okay, here we go. Are you guys looking at mine or are you looking at your own?
I'm looking at yours.
I'm looking at yours.
Okay. So now wait, why did I already see this one too? Oh, look at, I've worked all of them. I don't want the answers to already be, oh, here, start a new preview. There we go. Okay, here we go. Question 1. Let's figure these out together. A new 4-door sedan comes in 5 different colors with 3 interior options. It also comes with automatic or manual. How many different choices of cars are there? I have not shown you how to work these kind of problems. But I'll show you. But I have to switch screens again. So there's 5 colors, 3 interior, an auto or manual. How many different choices of cars? Do you think it's going to come out to be a lot?
Kinda.
Kinda.
I mean, it, like, the only way I could think about, like, solving that is writing all those words down and then just writing, you know.
Okay. And yes, I know exactly what you're saying. Okay, so here I'm going to bring up my camera and show you what Kevin is talking about. Okay, so 5 colors, 3 interiors, auto or manual. So Kevin says he's just going to try to write them all down. Well, I'm going to draw a picture of it. So there's 5 different colors. It didn't tell us what the 5 colors are. So we're going to make them up. We're going to say it comes in black, white, red, yellow, and green. And the 3 interiors are going to be, they come in striped, plain, or
Leather.
leather. There you go. And then auto or manual is just auto or manual. Okay, now we have abbreviations for all these things. So at first I'm going to list the 5 colors. And then if you get a black car, you still have a choice of 3 different interiors. So you might get the striped, the plain, or the leather. If you get a white car, you could still get striped, plain, or leather interior. A red car, striped, plain, leather. Are you getting tired of this already? I could list the same thing for yellow and green. I will.
It's sad because that's literally the only way I would ever get that right is by writing all that down.
You know, there is absolutely nothing wrong with doing it this way, except that I'm going to show you a trick that makes it quicker.
Yay.
Yeah, we like tricks, but it's good to see a picture of what we're doing here. If you get black striped, you still have a choice of automatic or manual. If you get black plain, you either get automatic or manual. Leather is either going to be automatic or manual. So you see how each of these original choices has branched out. And because of, and I could do this same thing for white, red, yellow, and green, except I'm running out of room on my page. But by doing it this far, I can see that for each different color, there's going to end up being 1, 2, 3, 4, 5, 6 different choices for each color. And we had 5 colors. $30 choices altogether.
That's a lot of choices.
It is a lot of choices. And I got that by multiplying. Now, this isn't the whole trick. The whole trick is, we're going to get the same answer. You just take each choice and multiply it. So this 30 we're going to get by taking 5 times
2.
times 2. Okay. This thing here is called a tree diagram. It's possible that the GED test would have a tree diagram already drawn on it and just ask you to read it. That's possible, but it wouldn't make that great of a question. But asking you how many total choices are there based on this situation, perfectly fair game for a GED test question. Okay. Go back to the six. This one. Okay, so I think it's 30. Let's see if it is. I like this about these lesson reviews because we can check the answer, and if you get it wrong, let's put a wrong answer in there intentionally. If you get it wrong, it tells you why that's wrong. But it lets you get one more chance to get the right answer. And I like that because sometimes you need just a little bit of a hint. So, but it doesn't let me choose it until I say, try again. There we go. Now I'm going to pick the correct one. Check it. And it is correct. Yay. And it tells me why. So you can learn a lot just from the explanations here. See? Okay, this is going to be the same. This is exactly the same question. Gives us a menu. Look, there's those appetizers, those entrees, drinks, desserts. You get a meal as an appetizer, an entree, a drink, and a dessert. How many possible meals are there? Well, Kevin, how would you like to draw this tree diagram? You'd need a huge piece of paper, and it would be really hard to keep all of those things.
Yeah, that'd
in
definitely
order.
be hard.
So we can use the multiply trick. We just multiply the number of appetizers by the number
1,
of
2, 3.
times the number of drinks times the number of desserts. So I'm going to go 3 times 1, 2, 3.
3 times 3 times 6 times 2.
Yep, you got it. And that comes out to be a big number. 6 times 3 times 2 equals syntax error. I did something. 3 times 6 times 3 times 2 equals, oh my gosh. Oh, look, we have to put the number in. What should I put in?
108.
Okay, let's see. Let's see. Yay, that's correct. All right. Let's see this. Rixa is casting a play. Where did they get these names? She needs to choose a lead and an understudy from 10 actors. In how many ways can the lead and the understudy be cast? Okay. So you have 10 people all together, and first you're going to pick the lead. So how many different people, if there's 10 people there and you're going to pick one of them, how many different people could you pick? Well, you could pick any one of the 10. So there's 10 ways to pick the lead. And then how many people are left to choose an understudy? Well, if you already used up 1 people, there's just 9 people left. So you can think of this kind of like, it is related to the menu question that we just answered. There's 10 choices for the lead and 9 choices for the understudy. That would be like 10 choices for the entree and 9 choices for the dessert. Different combinations could you get? So we can just multiply this. It should come out to be 10 times 9, which is 90. Let's see if I'm getting it right. Yay. Teacher feels really good when she gets it right, by the way. And the explanation here, 10 possible choices for the lead. That leaves 9 possible for the understudy. Top 5 paint colors. Keith wants to create a sale poster using 3 of the 5 colors. How many different combinations of 3 colors are possible? Okay, so I'm gonna do some writing here. So here we can think there's 5 different colors. They've named them really complicated things. I'm going to pick easy colors like green, yellow, red, blue, and orange. Okay, there's 5 different colors. How I could, we can, the first color we choose is going to be one of these. Let's say I pick green. There were 5 different choices altogether for that first one. Now that I've picked a color, there's only 4 left. So I'm going to pick another color, but there's only 4 to choose from. I'll pick some other color. Now there's only 3 left for the third color. So, I guess I just want to tell you, when you're trying to figure out all the different possible combinations, you're going to multiply to figure it out. Unless you want to draw out a tree diagram, which in this case would just, it would get really big and complex in a hurry. 5 ways to choose the first color, but there's only 4 left for the second choice, and only 3 colors left for the third choice. So yeah, 60. Oh my gosh. $60 there. What? Oh, did it say correct? Oh, it's incorrect. Okay, I got that one wrong. Does anybody know what I did wrong? Oh, I know what it's saying here. The problem is about combinations because the order of the paint doesn't matter. How does that change what we do? Oh, let's try again. At this point, I'm just going to guess another one, because at this point, I know I'm not thinking about it correctly, and I want an explanation. Okay, so I still got it wrong, but here's the correct answer. Let's see if I agree with it. Find the number of permutations. Okay, so their step 1 did the same thing that I did. They multiplied the 5 by 4 by 3 and got 60. Oh, I know what's wrong with this now. Okay, I could draw a picture of it. Oh, I don't know how to explain how they did it though. I get it. You know what I would like? Well, what I would like to do is I'd like to defer my explanation of this until tomorrow. My homework tonight is going to be to come up with an example of a problem that will be easy for me to draw so that I can show you what their process was.
Because on KT, I found also that like some things that I do on there, it just like the way they do things, it confuses me sometimes.
Yes, yes. And that's true with any book, any program, any teacher that you have. And the reason why is there's more than one way to do most problems, and there's certainly more than one way to explain how to do it. And everybody just picks their favorite. And it may not be the one that makes the most sense to a particular student. Okay, so anyway, that's my homework. I'm going to write that down. I'll forget it.
Okay, I definitely have to slow down and reread the question multiple times because I always read it too fast. And that's what gets you.
Yes. Yeah. And yeah, it definitely helps to spend more time in it. Okay, let's see if we can find another one that I can get correct. Carlton has a dime, a nickel, and 2 quarters. What's the probability that the first coin will be the dime? That one's easy. Anybody have a guess? So for this one, we just have to figure out how many coins does he have altogether.
It'd be 1/4, right?
Yeah, it's 1/4. He has 4 coins and only one of them is a dime. So the probability is going to be 1 out of 4. Looks like I got that one wrong too. Oh, easy. Or blue. Places it. Okay. It's 12 trials. Okay. So this, I like this question. Okay, hopefully I've given everybody enough time to read it. So he's drawing these things, these tokens out of the bag. He draws one, he puts back in. Draws one, puts back in. He keeps putting them back, so he always has 20 tokens in the bag. He does this experiment 12 times, and out of those 12 times that he does it, sometimes he gets blue and sometimes he gets white. How many times did he draw blue?
9.
9. And he drew 3 white. The question is going to ask us to make a statement about how many of those tokens in that bag do we think are blue? If we look at the results that he got, it seems like he usually draws blue. And that could happen easily if most of the tokens in there are blue. Right? And if they were all blue, I think he'd draw blue every single time. If they were half blue and half white, I think he'd draw blue about half the time and white about half the time. So as it turns out, he draws blue 9 times out of 12. So 9.
Wouldn't that be the highest percentage?
Yes, I love that. I love that, Kevin. Good for you. Yes. Just go right to the bottom line without doing any math. Yeah, if it's mostly blue, isn't it going to have to be the biggest percentage? We know he drew more than 15% blues. He drew more than half blues, so it's got to be 75%. Right? He drew 9 out of 12. And if you take 9 out of 12 and convert that to a percent, indeed, it comes out to 75%. Yeah, I love that. Kevin, you have some good test-taking techniques. You know that, and it's the GED test is a test. If you can save yourself some work, you know, look at all the work that they did here to figure it out. They should have just said,
Oh my gosh.
ask Kevin. All right, a box contains red, white, and blue tiles that are identical except for color. The colors are shown in the table. Oh, why did they do that? Which of the following changes could be made to the contents of the box so the chance of randomly selecting a red tile is 50%? Oh, don't look at the answers. Let's think it through before we look at the answers. If we want the chance of randomly selecting a red tile to be 50%, we better have 50% red tiles in that thing, a box. It's nowhere close to 50%, is it?
Nope.
Ooh. Okay, so here's our choice. Either add red 5s, remove 5 whites and 5 blues, add 10, or add 20. Gosh.
How much columns are there, long-wise, height-wise?
Yeah, So you're right. That's where we need to start. How many of them are there all together? How many tiles are there all together? 1,
So 40.
2. So there's 40 tiles now. And there, it looks like there's 10 reds. 15 blue.
So we would have to add 25%.
Why do I get 14? That doesn't add up. I'm adding these up wrong. And is that a gut feeling guess, or did you do some calculations?
Well, just adding up the columns and then adding up the reds. 10 over 40 is 1/4. So that's 25%. And if you want 50%, that's add 10 more. So if we add 10 tiles. Okay, so remove 5 white and 5 blue. Let's see.
I still haven't figured out how many white tiles there are. I haven't counted them correctly. I have to count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
There's 15 of them. Okay. All right. And we want, okay. So let's just, with this one, really, we're going to have to look at each of these answer choices and see if one of them would work. So if we add 5 red tiles, we'd have 15 reds, 15 blues, and 15 whites. That doesn't give us 50% red. It ain't A. If we remove 5 whites and 5 blues, we'd have 10 reds, 10 blues, and 10 whites. That doesn't do it either. If I add 10 of each color, that'd give us 20 reds, 25 blue. No, that doesn't do it either. Maybe this one?
I think that would have to be the answer because those other ones don't make sense.
No, the other ones don't make sense. If we had 20 red tiles, then altogether we'd have 30 reds, 15 blue, and 15 white. Yep, that 10%. Oh my gosh. Personally, I like questions that I can just answer. I don't like to have to figure out which of their answers works. Okay, we got it. And really,
Gotta rattle some brains, Mary.
look what they did. Do you have all this stuff?
Wow.
That's weird.
Oh my gosh.
I don't like that. You know what they did?
Whoa.
They tried each choice just like we did. And then something here that you're seeing here, that's
I
Like,
have
what does
no
that
idea.
even mean?
a computer thing. It didn't mean to show us that.
I'm all trying to make sense of it. I'm like, how did they do this? Like,
Oh, they're starting to use a whole nother language now. No wonder why people get confused. Okay, Karen plays spin to win. What's the probability that Karen will win a large pizza? Oh, no, a large prize. Gosh.
oh my
She's
God,
you're
winning a
hungry.
pizza would be so
Well,
nice.
why did I think of pizza when I saw this thing that looks just like a pizza?
It does look like pizza. It looks like it's a cut pizza.
Getting hungry, Mary?
I am
I'm hungry.
I am hungry. Part of my kefir wasn't ready this morning, so I couldn't have kefir for breakfast. And I did say kefir and not beer. Okay. Large prize. Spin the letter A twice. Okay. So we have to figure out what's the probability of spinning A twice. What's the probability of spinning A the first time?
1 out of 6.
1 out of 6. Okay. And we're going to do it again. What's the probability of spinning A second time?
2 out of 6.
No,
Still 1 out of 6.
it's still 1 out of 6. Yeah.
But if it was added together, it'd be 2 out of 6.
But we don't add them. If we
I
add
know.
them together, it would be. We don't add them to figure out a probability of a compound event. So when you have to do more than one thing all together, we end up multiplying those fractions. So 1 times 1/6 comes out to be
212. No.
1/12, right?
you multiply the top,
Let's see.
multiply the bottoms. So
Oh,
1
1.
is 1, and 6 times 6 is
36.
it's this one. Oh. And let's see if they do it by multiplying. Oh, indeed they do. Figure out the probability of A, still the same, and they multiply them. Next. Oh, manager rights. Looking. Okay. So there's 12 people. What's the probability we'll choose Grant? 1 out of
12.
12. Now they're not going to make Grant work Friday and Saturday. So he's out of the pool. But they're going to pick somebody else to work Saturday. So how many are left?
11.
There's 11 to choose from now. Yeah. And Anna's only one of that 11. So we still have to multiply, but this time the probabilities are not exactly the same. With that spinner, the probabilities are the same. This is different because we took one guy out. So it's going to be 1/12 times 1/11. Does anybody know what that comes out to be? And interesting. So we could use the calculator just to multiply 1/12 times 1/11, which I'm going to do. And when you multiply those, they come out to be 1 over 132. So which of those answers looks like 1 over 132?
The first option.
Yeah. Kind of weird because they don't show it as a fraction, but that's still the same thing. Hopefully I got this one right. I'm all self-conscious now that I got one of the answers wrong. Yep, and that's what they do. They multiply them right there. Right, we have time for one more. Are you guys working this a little bit?
Yeah. Not it.
Anybody get an answer already?
But would a fairy be considered an animal?
I know. I was reading that. I thought, oh my gosh, I guess I'm just going to call the cows and the cats animals. Everything else is not. Oh. I did it wrong. I did it upside down. Okay, now I think I got the right answer. Hey, anybody have a guess yet? So, one thing that we can do, this is what Kevin's doing. I'm positive. Now that Kevin has decided that out of all of those costumes, there's only 6 that are animals. There's a whole bunches that are not animals. There's a lot more not animals than animals. And so we're looking for the ones that are not animals. Well, there's more not animals than animals. So it ain't 30%. It has to be one of these other bigger percents. So I can eliminate this answer right off the bat without even adding or anything. So anybody have a guess yet?
C maybe? I'm not sure.
Well, that's a good guess. I'm going to show you what I did. I'm looking for a clean spot. So we have 4 cats, 6 skeletons, 3 robots. 1 bear. Oh, I don't know if I got it right. 2.
I got A on this one.
Yeah, and that's what I did too when I did it wrong. Okay. Okay, so I think I did it wrong anyway. Let me make sure I wrote everybody down, and then I'm going to switch screens on you. Okay, we don't want the tree diagram. We're just looking at this part. There were 4 cows and 2 cats, or was it 4 cats and 2 cows? Anyway, there's 6 that are animals. And there's 6, 7, 8, 9, 5, 14 non-animals. 20 total, 20 different costumes. So the question said, what's the probability of picking one that's not an animal? So we want this, 14 non-animals out of 20.
I think it's 80%, but I'm not sure.
14 out of 20 to turn that into a percent. So 14 times 100 divided by 20 came out to be
20%.
Oh, it comes out to be 70%. So Joe, do you see where you got your answer of 30%?
Yeah, I took the wrong one. Yeah.
Yeah. And that's what I did first too, because I didn't read the problem.
No problem. I got to read thoroughly.
Yeah. And notice that out of the answer choices that they gave us, the very first answer choice that they gave us was 30%. So they're always going to put you know, the obvious wrong answer on there too. All right. So I'm done. Are you guys done? Do you need anything else from me today? I'll stop
Good.
recording. I'll send you the video when it's done. And for your assignment today, you want to work on section 3.3. And it's going to be the section that covers all those kinds of questions that we just practiced. So hopefully it'll just be an easy review for you.
I should I'm gonna go into the video when you send it
Okay,
so
okay,
I can answer it.
yeah. They
Just kidding.
do go into an explanation of the difference between a combination and a permutation, which is where I blew it on that one question that I didn't answer correctly. So you guys might be ahead of me by the time I have an explanation for you tomorrow. Okay, so I'll finish the video, send that to you, and see you guys tomorrow, right?
Yes.
Bye.
Bye.